we're hearing, oh, well, it's all about the antibodies, right? You got to get the antibodies. The vaccine, you know, they're saying, well, the Moderna vaccine had created more antibodies than the illness itself. And then we're, you know, hearing, well, maybe the antibodies don't actually work. The antibody test can give you a false report. COVID-19 immunity, CDC warns, don't trust the antibodies. WHO says jury is still very much out on whether coronavirus antibodies provide immunity. And this has been the big argument, confusing all of us, right? But what if it has nothing to do with antibodies? What about that? You would almost think that that's a crazy thought. Like, is there something in our immune system outside of antibodies? There actually is. There's been articles coming out over the last week or so talking about T cells, the presence of SARS-CoV-2 reactive T cells in COVID-19 patients and healthy donors. Multiple articles. T cells may help COVID-19 patients and people never exposed to the virus. We're seeing that people are able to fight off the virus that never even saw it before. Now, this may play into asymptomatic carriers, but what we know is essentially what they've always known, that T cells are a massive part of your immunity, and it's something that we never, ever hear about. I want to bring out a very good friend of ours, Dr. James Neuenschwander, to discuss T cells. This is something that is really starting. I think it's about to light up, right? Of course, we're hearing it here on the high wire for the first time, but I guarantee you over the next couple of weeks, there's going to be a growing discussion about T cells because there's a lot of studies now showing that antibody production may not be the most effective part of your immunity to COVID-19 or even other illnesses. But for those of us that don't even get this, what is a T cell?
Okay, so a T cell is part of your immune system. It's part of what we call the adaptive immune response. So there are different types of T cells. There are T cells called T helper cells. The function of these is to help the B cells make antibodies. They're involved in the immune response. They can also call in the other types of T cells, which are cytotoxic T cells. These are more like commandos that will go after viruses all by themselves. You know, the trouble with antibodies is antibodies will work outside of the cell. So if you're dealing with a bacteria, then that's great. Bacteria are outside of cells. But these viruses are inside a cell. So when a virus enters a cell, that viral particle is going to be picked up usually by macrophages. These are another type of white blood cell. The macrophage will process that, put it on the surface, and I think that's what your video is showing here. It'll put it on the surface with a marker that says, hey, T cell, come on over here. And it'll bring in either a T helper cell or a cytotoxic T cell or even something called a killer cell. And it will bind with that receptor and it'll say, hey, T cell, killer cell, this is your target. Go get them, tiger. The T cell is then going to go start duplicating itself, start going after the target on its own if it's a cytotoxic T cell, or if it's a helper T cell, it'll induce those B cells to make more antibodies. So B cells can work on their own, but they do much, much better by getting support from the T helper cells. And then T helpers, I mean, you know, you start subdividing these things. The basic subdivision with T helpers is you have Th1 and Th2 cells. So Th1 cells are the ones that call in the cellular immunity, you know, those cytotoxic T cells. And then the Th2 cells are the ones that tell the B cells to make antibodies, and they're going to be involved in that antibody response. And so the balance between those two make a difference. And that's part of what was talking about in that paper.
Now, when we look at vaccines, you know, we always hear about antibodies. We're always hearing about the B cells. And vaccines wear off. It's one of the biggest problems. And we know that they've been spelunking deeper and deeper in the immune system with these newer vaccines. You and I have both been at these ACIP meetings where they're discussing, you know, different approaches, whether it's a DNA vaccine or an mRNA vaccine, you know, triggering, you know, the parts of the immune system that vaccines have never gotten to before. Now, this becomes problematic, though, doesn't it, when a lot of our testing is antibody related. And many of these studies that came out this week are talking about the fact that after you have the infection, many people, the antibodies wear off quite quickly with coronavirus. And the WHO is trying to say, well, that means that you don't have immunity anymore. But these articles are saying, and by the way, the WHO even knew this years ago, T-cell immunity may be the most important immunity, and that can hang on. So where are we at? Because it just seems like we're like in this old school world where we're discussing everything based on antibodies, but the real truth is that T-cells are proven to be the more important discussion. I don't hear any T-cell tests going around the country. You know, how many people have, you know, the T-cells needed to fight this off? So is this, you know, how does this weigh into why are the antibody tests maybe not accurate as to whether or not you have immunity? And this question really, I think probably the biggest one is they're trying to say there's the potential you may not have immunity after being infected. What about these T cells tells us that that may or may not be true?
Okay, so this gets a little bit complicated, and again, the immune response, it's a beautiful thing, it's very complex. We're talking about one little piece of it, and when you're talking about antibodies, you're just talking about some random piece of it. And like I said, antibodies are not as important for viruses because the viruses are inside the cell. The antibody can prevent the virus from getting to the cell, but once it's in the cell, the antibody's not going to work. So what these two studies showed, and one was from a group from the US, and another was from a group in Europe. So the group in Europe had looked at, and both of these are relatively small, and by the way, this stuff, like everything else we talk about, you know, it's not officially published, it's put online, so this stuff may change over time, but what they're saying is that...
So let's just say right now, these are the theories, right? These are going, we can use the word right now, what we're presenting to you, which, by the way, everyone on the planet, and I'm going to make this even more clear after I get you back into your office, but we're so confused. I mean, every scientist in the world is throwing out a different theory, hoping if I end up being right, I win the Nobel Prize next year, right? But the world is putting forth theories. So let's discuss the theory of T cells right now.
Yeah. So what they found was they looked at people that had COVID, and they isolated their T cells. So these are both T helper and so we call T helper cells CD4 cells, and we call the cytotoxic T cells CD8 cells. So they isolated CD4 and CD8 cells from these patients, all right? And then they looked at, do these cells react to spike proteins? Do they react to some of the other proteins that are specific for COVID? All right. So what they found was the people that actually had the disease in the U.S. study, and it was around 20 people, 100% of them had reactive helper T cells to the spike protein and the other three proteins they looked at. The group in Europe, they only looked at spike protein. They split it in two and looked at, you know, do you react to one part or the other part? And there it wasn't 100%, it was about 83, 84% had T cells reactive to it. Now remember, we're not talking whether or not they had antibodies. We're talking about, do they have the cells that mount that immune response? And what's interesting is when they identified what type of T helper cells these are. Were these the Th1? Were these Th2? What they found out is 100% had the markers for Th1. So these are not T cells that support antibody production. These are T cells that support cellular immunity. So it's suggesting that if you want to know if a vaccine works, you're going to have to do one of these T cell assays to figure out if you're generating cellular immunity. The level of antibody doesn't appear to have factored into this. The other interesting thing about these articles is they also looked at people who had not been exposed to COVID. And what they found was about 50% of them, they didn't have T cells reactive to the spike protein, but they had T cells reactive to the other COVID proteins. So there may already be some built-in immunity just from exposure to other coronaviruses. And that's
like
pretty cool.
Like we've all had the common cold, which, as Dr. Bregan just pointed out last year, if you had a common cold, they're finding that your body has already able to recognize proteins in the common cold. This is another coronavirus that may have a different spike protein, but they're finding you could have success fighting it or beating it if you also, your body's just recognizing those proteins you got and understood, your body understood from last year or 3 years ago from a common cold. So we may have people that will never get this illness or are already fighting it off that had essentially an immunity based on a common cold last year. Am I understanding that right?
Yeah, that's the idea, that at least 50% of these people had, you know, we call them cross-reacting. They had helper T cells that cross-reacted to the current coronavirus, even though they had never been exposed to it. No, it's awesome stuff. And they also, we know one of the other theories out there as to why some people do very poorly and develop this cytokine storm and die from the virus, and the vast majority of people don't. It really has to do with the cellular immune response. So if that virus gets into the cell, the first thing that happens is that cell cranks out interferon. Interferon all by itself, without calling in any other cells, will destroy the virus before it ever starts. The interferon calls in those T cells. All right. So one of the reasons why some people don't do well with corona seems to be because the virus has learned how to suppress that whole response. And so if people don't have a good cellular immune response, and guess who doesn't have that? The elderly. And guess who has a great cellular immune response? Little kids. All right.
So essentially, the way I see it is it's like a bunch of terrorists bust into your house, and the first thing that goes off is the bomb. You set there, boom, and then everyone that's left is the soldiers running in to take out the rest of them. Is that basically how it went? We have a natural set smart bomb. You open that door, come in, we're going to blow you up, and that's something the immune system does all by itself. That is awesome. And it makes me think, you know, why I'm more and more I geek out on this stuff, because the human body and the immune system is so fantastic. And when I think about how small-minded in one vaccine, they're trying to do one thing with one coronavirus in a vaccine or an RNA, these small-minded scientists that want to try and do something where we have such a brilliant system to mess with it outside of how it's already working, it defies reason. And by the way, you know, once you see people that own stock and are a part of creating the vaccine jumping ship the way they are, I think what I want to do is say that really we should be really happy with how well our body naturally responds to this, should we? Is that what we get from this? Your body already kicks ass when it comes to COVID-19?
Absolutely. I mean, it's what Zach Bush was talking about a few weeks ago on your show. I mean, it is so true. We've had millions of years to evolve with these things. Our bodies know what to do. Give our body the nutrition, give it the ammunition it needs to do its job, and it will do its job. And you know, we don't need to cower in our basements. We can sit here and do stuff to support ourselves. You know, like your previous speaker was saying, get some good nutrition, get out, get some fresh air, get some sunshine. You're going to do okay with this. You know, that 0.2% mortality rate, that's for the population in general. If you're talking people 20, 30 years old, it's pretty much zero. I mean, not that 0.26 is much above that, but it's zero.
0.2 is technically below, you know, it's zero. It's 0.2, but you're right, 0.00. We get to stack a bunch of zeros on the other side of that decimal point. Dr. New, I know you got to get back to your patients. I want to thank you for taking the time. Actually, it was very helpful. I mean, that is the first time I think I really have, you know, understood T cells.
If you like that clip, then be sure to check out our live broadcast of The High Wire every Thursday morning at 11 a.m. Pacific Time. You can watch it on Facebook, YouTube, iTunes, and Twitter. We'll see you there.